Hey guys, this is Saptarshi here and welcome to our YouTube channel. So today we are going to discuss regularization with early stopping. Okay, and this is a hands-on session, so it will be done using our Kaggle notebook. This will be available as a public notebook for all of you. Alright, so let's quickly revise what is overfitting. Okay, so here if you see, there are three models that are being displayed. Okay, so this is a binary classification problem. Okay, and this blue circles represent one class and the plus sign represents the other class. Okay, and all these dotted lines, right, all these dotted lines actually represents the models or the decision boundary corresponding to the model. Okay, so at a very initial level, you can have a very simple linear boundary like this, and which may not explain the data very well. Okay, where you say that underfitting is happening, and on the other extreme, what happens is that the model tries to memorize the data almost. Okay, so it follows the data boundary very closely, and it kind of goes crazy in getting 100% accuracy on the data set. As a result, it does well on the training data set, but it cannot replicate that performance on the testing data set. Okay, so we call this tendency as overfitting, or we say that the model is not able to generalize well. Okay, and this is what we actually want, which is a good compromise between the underfit and overfit. Now let's quickly revisit the relationship between overfitting and model parameters. Okay, so this is another simple example where what you are trying to predict is the price of the house, and only one input is given, which is the size of the house. Okay, three models are there. The first model is a linear model, has two parameters. The second model gets a little bit more complex. Okay, so you have three parameters. And finally, the last model, which actually follows the data points exactly, has five parameters. Okay, so you can of course understand that this is the model which is overfitting, isn't it? And it has most number of parameters. Now, what is the connection of parameters with neural networks? Okay, so you know that compared to your normal machine learning models, your neural networks has much more number of parameters. So that is the reason overfitting is more pronounced in case of neural networks. And we discussed different regularization techniques. Okay, so regularization is a tool to handle or combat this overfitting. And one of the most simple technique is called as early stopping. So what happens is that out of the training set, so you already have a training set, you already have a testing set. Now out of the training set, you carve out some amount of the data and you call it as a validation set. So you train your model on the training set. So this red curve actually indicates the performance on training set. Okay, so this is measured in terms of RMSE, root mean square error. Okay, and generally on the training set, as you move from one epoch to another epoch, the performance becomes better because of this tendency of overfitting, because neural network has high number of parameters. However, if you at the same time continuously test your model's performance on the validation set, right? So you train in the first epoch, test on the validation set, and you plot it, you will see after some time. So here if you see maybe around 240 epochs, the performance is no longer decreasing, it is going up. Okay, so early stopping actually indicates that you do not go up to all the epochs that are being specified, but stop when there is no improvement on the validation set. Okay, so this actually gives you two advantages. One is, of course, you have a less training time, right? You stop at a much earlier epoch. And secondly, it is a regularized model, so it is not overfit. Okay, all right, so now let's see how we can do that using TensorFlow and Keras. So TensorFlow or Keras has a feature called as callback. Okay, so as we were telling that we need to look at that testing accuracy or validation set accuracy, right? So when the model is being trained, right? So if you consider the model as a black box, you need some kind of windows to see through and see whether the model is performing well or not, its accuracy is getting saturated or not. Okay, so this mechanism of fitting windows, okay, is called as callback. And where all you can fit your windows, so you can attach it to the fit process of the model, the evaluate process of the model, and the predict process of the model. What all you can observe fitting these windows? So it turns out that there can be separate windows for separate purpose. So one can be for saving the model, one can be for monitoring, and you can write your own custom callbacks as well. Okay. Now, even unknowingly, we were actually using some base callbacks. Okay. So when we were looking at how the accuracy or loss is performing, okay, on the fitting of the models, that is actually a basic callback, giving an understanding what is happening in the model. Okay. Now let's go and look at early stopping mode. So early stopping is an object by itself, and it takes several parameters which we are going to look in a short while. But this is where I am creating the window that I was talking about, and we have passed few parameters like patience and restore best weights. So I will discuss about this in a short while. And then I said that this window can be attached to fit. So we have attached it to something called as callbacks. Okay, so this is where you can fit a window, and this actually tells you that it is not one window or one type of window that you can fit. You can fit multiple types of window. So here though, we are going to concentrate only on early stopping window. Okay, now let's quickly look at the parameters it has, right? So one parameter is monitored. So what is the quantity that you want to monitor, right? So you are just kind of going to attach some kind of a sensor, okay, to visual sensor to the quantity that you are going to monitor from the window. Okay, mean delta is minimum change in the monitored quantity. Okay, so how much you will allow to consider it as an improvement, right? What is the precision? Patience. So this is a very important parameters. Number of epochs with no improvement. Okay, so if you keep your patience very low, as long as in any epoch you get your performance degrades in the validation set, you come out. Whereas if you keep a higher value of patience, then you can allow that for multiple epochs to happen. Mode is auto, mean, and max. So this depends on what kind of parameters it is, right? So mean is it will look at, or it will try to see that it is going down. So RMAC, right? We saw that it was going down from epoch to epoch. If you are looking at accuracy, you will go from go up from one epoch to another epoch. So you will use max. And the best is auto. So it can look at different runs and understand whether it is a mean or max based on how initially monotonically which direction it is going to. Okay. And restore best weights is like if you have if you are coming out at patience, okay, patience level at 10 epochs, okay, and your best validation accuracy you got at 8 epochs, okay. So restore best weight, if you set it at true, it will take the weight of the 8th iteration, and if you don't use the value as true, it will give you the weight parameters of the 10th epoch. Okay, all right. Now let's do our regular housekeeping of importing the libraries. Okay, and we are going to use our regular Fashion MNIST dataset. You know about the dataset already, right? So it is a 10 class classification dataset, very similar to our 10 handwritten digit recognition problem. However, here the classes are 10 fashion items. Okay, so this dataset is preferred more because of the diversity that it has got. And then there is we already had a train level and test level. From the training set, we also created a validation set. Okay, so this is one of the very important steps to look at. Okay, all right. So after that, we need to of course standardize the input. So as it is a pixel value, just dividing by 250 will standardize all the inputs, and we do that for all of training image, test image, and valid image. Okay, all right. So now let's create the model, and we are going to create a very simple model. So we are going to, so all these are actually images. Okay, so we have to flatten it. So this is a 28 into 28 image. So we are changing it to a 784 into 1 image. We are using only one hidden layer with activation as ReLU, and we are adding the final layer. Okay, which has an activation of softmax. So you know, whenever it is a multi-class classification problem, you know, it is the softmax activation that we use. All right, and we are actually using two models. All right, so one where we'll use early stopping and another we will not use early stopping. Okay, and then we are going to compile it. So compilation, you already know the loss is sparse categorical cross entropy. So you know there is also categorical cross entropy. So if your target is in form of a one-hot encoding, you use it as a categorical cross entropy. Else you use this sparse categorical cross entropy. Okay, and then you compile these models. Okay, and what we next do is we first what we do is we fit this for 50 epochs, and we are not using any callbacks over here, right? So it will take quite a lot of time to run. So I have pre-run the model and the result is stored. Okay, so what we are going to look at is the training accuracy and the validation accuracy. Okay, so, you know, this is what is happening. The training accuracy is continuously increasing, right? It is going up to 0.98. However, you see that the validation accuracy is saturated around zero point 0.9 or even lesser at 0.8, right? So this is what is a good sign of early stopping. So this is a place I will stop. And I can be completely misguided and go all the way around getting better testing accuracy, right? Okay. All right. So now let's evaluate this model and see how it is doing on the test set, right? Okay. So we are getting an accuracy of 88.8%, which is of course not bad. Next, what we are going to do is we are going to use a callback, and we are going to use patience equal to 4. So we are allowing at least, you know, 4 cases where you will allow the validation accuracy to fall, and we have set restore based weights as true. Only thing that we have changed between model and 1 and model 2 is this fit method, where we have attached this window. Okay, and if you see that we have not used what we are going to monitor, so by default this actually monitors the validation loss. Okay, all right. So now let's run this. I think it is already again run, so we are not going to run this, uh, or I can quickly show you. Yeah, so it will take a little bit of time because, you know, there are 50 epochs. Okay, and you see that it starts with a good accuracy, and training accuracy is improving. Okay, training accuracy is improving quite a lot. Okay, and from epoch to epoch, just look at where there will be so you see here, though your accuracy is increasing and loss is going on the training set, on the validation set, if you look at, it is not always it is going down or something like that. Do you see that, right? So here loss has gone down, but then it has increased. So after 9 epochs it has stopped, because at least it has got 4 cases where, you know, it has not monotonically decreased. Okay, so, you know, this is one case where it has not decreased. Okay, this is one case where it has not decreased. Again, this has not decreased over here, and then more probably finally on the 10th set also it has not decreased. And now if I run this, if I run on testing set, you see that our accuracy is 89.24%. So that's the crux of what we wanted to tell, that we used early stopping as a regularization mechanism. So as a result, you know, if we go back to this particular graph, okay, so we actually stop over here. We don't go all the way up to here. And not only that, you know, we are not compromising on the test set accuracy. Here the test set accuracy was 88.80, and we have got an 89.24 accuracy over here, right? So, you know, this is one of the fundamental advantage of regularization using early stopping. I hope you got a good understanding. I highly recommend, you know, you run this on your own and get a solid understanding. Okay, thanks so much guys for watching our video, and give like, comment, subscribe. As usual, a request to all of you.